at YouTube. If you have any questions, I will be more than happy to answer. Please fire away questions. I will just put the chat box here at YouTube. So I hope many of you are enjoying the course that is coming up that I am teaching on biophotonics. As you all know, biophotonics deals with the interaction of light, photons. Photons are light particles with biological matter. Photonics is a vast subject in itself. Electronics deals with manipulation of electrons, and for various utilization, you see what are the different application of electronics. Photonics is the next step. Photonics mostly deals with the manipulation of photons, manipulation of light particles. Biophotonics is a specialized branch of photonics that deals with the interaction of light with biological matter for two most important goals. First, detection and identification of a disease as early as possible during the onset of the disease, and that disease could be communicable as well as non-communicable. Communicable where a foreign body, a foreign particle invades human body, and a non-communicable disease, something that happens because of some anomaly happening from inside the body, like say protein misfolding disease, Alzheimer, Parkinson, something that happens because of some genetic mutation or some other ailment that has no external cause. Everything is internal. So both of these diseases we want to detect at a very early stage using light. And the next most important goal of biophotonics is, once detected, we want to make some kind of a therapeutic intervention, i.e., we want to see some kind of a cure. We want to find if this problem, if this ailment that we have got, if that can be cured, if that can be removed, if that can be recovered. So these are the two most important aims or goals of biophotonics. I assume that this has been discussed. Since I have discussed this, I assume you know it already. So let me take on some of the questions that you all have asked me from the session. So Gayatri Bhattad asked me, I'm sorry if I'm not pronouncing your name properly. Gayatri asks me, first of all, I'm very happy with the whole series of lectures. It's very interesting, sir. Thank you very much. Thank you for this. Well, thanks to you. My question is not related to syllabus, but related to practical knowledge of biophotonics. I'm an MSc Biotechnology first year candidate at, I'm not going to read your university for privacy's sake. You are a biotechnology student. We have to go for compulsory 2-month summer research internship. I wanna know what places in India will give me a short summer training of biophotonics. My research interest lies specifically in immunology. I am going to do dissertation in immunology at 2 years. So it's good time to learn those techniques and integrate it in study. Will you supervise me in summer or any other institute? Please suggest. Well, Gayatri, thank you. Thank you very much for liking the course and asking me if I can supervise. So see, Gayatri, as you mentioned that you are a biotechnology student and you want to, your research interest lies specifically in immunology. I'm not an immunologist. I am a nanotechnologist or nanophotonics for that matter. You can, of course, apply. I would strongly suggest you to apply. There are several research groups, both India as well as abroad, which are working on biophotonics. Since I am not from immunology area, I cannot tell you which groups works in immunology per se, Biophotonics wise, there are several fantastic research groups in IIT Madras, IIT Kanpur. There is National Earth Science Center that's in Trivandrum, to the best of my knowledge. Then there is a Biophotonics laboratory in Manipal University. If you are looking for specifically immunology, then probably the NCBS in Bangalore is one of the best institute, world-renowned, world-class. So these are the places that you should look for. Obviously, the list is not exhaustive. There are several other areas where there are other places where biophotonics is being dealt with, as I said, both here in this country as well as abroad. So you have to look. Internships, especially in IITs or especially where I sit, IIT Kharagpur, is competitive. So you have to apply early, and then probably it's on the discretion of the principal investigator. It's on the discretion of the professor whom you have applied, depending on whether there is a requirement per se on her or his lab. You will be chosen. So that's the only advice I can give. What else? Let's see. Hassan Rob, good afternoon. Sandeep Chatterjee, good afternoon at all. Gayatri Bhattar, not looking for specifically immune. So you have changed your interest. You wrote you are looking for specifically immunology, Gayatri, but now you are saying you are not. But it's all right. Apply to several different biophotonics laboratories. There are several of them, both IIT Kharagpur as well as, I don't know, IIT Madras, IIT Ropar, very strongly coming up. IIT Gandhinagar has a very, I think I said that as well, has a very strong ultrasonography group. You can try that, though ultrasonography is not technically biophotonics, but you can get something there. Good afternoon to all of you. What else? Other few questions. Amit Kumar Yadav, your question is Madhya Pradesh. That's it. Amit Kumar Yadav is asking me Madhya Pradesh. I don't understand. You want to know if I am from Madhya Pradesh or have I been to Madhya Pradesh? I don't understand the question, Amit. If you are here, then you have to write the question. The question field, you have simply written Madhya Pradesh. Well, are you looking for biophotonics institutes in Madhya Pradesh? I'm not sure. I'm not sure if there are any. I do not know. I do not understand the question. You have to ask me specifically something bit more than this. I require. Shubhrojit Sarkar asks me. Let me see. Shubhrojit Sarkar asks me. I'm missing it. Hello, sir. I'm very much. Hello, sir. I'm very much interested in neuro instrumentation, especially in brain-computer interface. Apart from very common technique EEG to collect brain signal, there is a photonic-based technique called NIRS. Show some light on the topic of NIRS. Shubhrojit, if you are listening, you didn't spell out what NIRS is. Probably this is your way of testing me. So it's all right. So Shubhrojit, NIRS is basically near infrared spectroscopy. If you see in, I think, session 4 or session 5, I discuss a detail on spectroscopic method. I have discussed UV visible spectroscopy. At the same time, I have discussed FTIR spectroscopy. NIR spectroscopy, near infrared spectroscopy, is something that is falling in between UV vis as well as NIR. UV vis goes into up till say 300, 200 nanometer to roughly around 750, 800, 900 nanometer wavelength. infrared spectroscopy, most infrared spectroscopy, the run-of-the-mill FTIR spectroscopy starts from around 2 micrometer wavelength, that is 2000 nanometers to 1012 micrometers. So the gap between 900 to 2500 nanometers is the near infrared, and it is coming up. Near infrared spectroscopy is coming up, but see, the technique is very much similar to Shubhrajit. The technique is very much similar to infrared spectroscopy itself. There is nothing extraordinary different between near infrared spectroscopy and infrared spectroscopy. Just the range is quite different, and since the range is quite different, the wavelength is quite different. It has its own advantages and disadvantages. You know, scattering is inversely proportional to 4th power of lambda, Rayleigh's law. That's how sky is blue and it becomes red during sunrise and sunset. It's a high school question, high school physics question. So the scattering, depending on the wavelength, will change, and thereby you might have different penetration depth, different types of photons that will come out. So it has a slightly different application, and you rightly said that it's a tool for neural imaging. So there is a topic coming up in the last topic, that is neurophotonics or optogenetics, where I will be discussing quite a lot about several of these techniques, as well as something else. But NRIS, near field, NIRS, near field infrared spectroscopy is very common, very similar to FTIR. You learn FTIR, you will be able to get that. Okay. So Manish Singh, thank you. Manish and I communicate quite a lot. He is, I believe, genuinely interested. He asked me several questions, and I am quite pleased with his curiosity. You know, this is what let us teachers, educators go forward. These are the students who always keep us onto our toes. Like, I look forward after every session to get questions from Manish or Prashant or Chandrasekhar, who keeps on asking me very important questions, very good questions. So thank you very much. Manish asks, he's interested to do PhD in biophotonics. Manish, I think you are already working somewhere. You are already working in public sector. So are you going to leave your job to do a PhD in biophotonics? Fine, it's obviously your choice. If you want to do PhD in biophotonics, that's fantastic. We want our tribe to grow. We want our tribe to grow, and why not? Apply to several different biophotonics laboratories, different professors all over India as well as abroad. Apply to several places, show them that this is my interest, this is the area where I want to work, these are my ideas. So I would like to work. Let's see what kind of response you get. Om J said, good afternoon, sir. Well, good afternoon to you as well. Vishakha, good afternoon. Sandeep, good afternoon. Hassan, I have already said good afternoon to you twice, so I'm not going to say third time, but you are obviously welcome to stay. Why did Hassan retracted the message? Okay, one more question from this gentleman called Prashant Sharma. Okay, let's see what Prashant Sharma asks. Hello, sir. I'm an MTech student in wireless and optical communication. I'm not going to read the name of your institute for the sake of privacy. Okay, you are an MTech student. I want to ask you that what is the future of biophotonic and what are the latest hot research areas in this field? How can we use machine learning in this technology? Well, Prashant, thank you for your question. Good luck with your MTech. So if you look at, I think, lecture number 2 or lecture number 3, I discuss quite a lot about what is the future of photonics. I think I have the slides here. Future of biophotonics is in 3D imaging of cells, pathogens, nucleic acids, simultaneous physical and chemical imaging. So this already exists. I have already discussed what are the future of biophotonics. So these are the hot topics. I am teaching you some of the hot topics, like if you look at the syllabus, I think from chapter 6 onwards, after the introduction part, all of them are hot topics. I am working on them. I am working on imaging beyond the diffraction limit. I am working beyond for ultra high sensitive biosensing, biodetection. So those are obviously there. And what else? What are the other hot topics? Biophotonics is bourgeoising field, so anything that brings in two-dimensional materials are quite getting popular for their unique optical and electronic properties. I hope they will find some very good potential in biophotonics, especially in the therapeutic sense. Photothermal therapy, photodynamic therapy, I haven't taught you that yet. I will be teaching you in, I think, chapter 8. So two-dimensional materials, these are the hot topics. New materials, new drugs, discoveries, new imaging, new sensing, these are the hot topics. How machine learning will be used here? Well, machine learning is a tool that at the end of the day, to the best of my knowledge, is pattern recognizing, right? You teach the software, you teach the algorithm based on certain sets of data. The data needs to be created first, and then the algorithm picks up something unknown and refers it to its known library and try to make some kind of a guess estimate, an intelligent guess. And it has its own advantages and disadvantages. So it is coming up. So whatever image that you are taking from photonic technologies, or whatever biosensing you are doing from photonic technologies, those images or those output signal that is coming up, machine learning can be utilized there to analyze those results, and thereby come to some kind of a conclusion, that this might be this disease, or this is the progression of this disease. So machine learning, like any other field, you are using machine learning in almost a plethora of field these days. So that is coming up strongly in biophotonics as well. Okay, let's take up some topics from the YouTube chat. Hassan says, sir, I want to ask about role of biophotonic in cell biology. Previously, we used radioactive isotope. Very, very good question, Hassan. So you know about biophotonics imaging, photonic imaging. You can actually go for non-ionizing radiation. So biophotonics deals mostly with long UV to IR range. So those are non-ionizing, and you do not need to give some kind of a radioactive tracer. So radioactive tracer, well, is radioactive in nature and can destroy. We are coming up with several new materials, for example, biological materials, beg your pardon, two-dimensional materials, which can fluoresce upon excitement of light. So these specific materials, these fluorescent materials, can be made to tag at specific organelles or specific parts of a cell, and after shining a specific wavelength of light, it will fluoresce, and that fluoresced light can be detected through a optical fiber. So this is kind of like an optical biopsy. So biophotonic in cell biology can be used for optical biopsy instead of radioactive isotopes. So optical biopsy is where you will be getting information on cell biology. I'm reading that they are trying to, perhaps you have also gone through the topic of optical coherence tomography. I discussed this in, I think, chapter number 6. Optical coherence tomography, they are trying to minimize or maximize the resolution per se of optical coherence tomography. So that is also the future where we will be able to image single cells. If you have seen my topic, my lecture on AFMIR, atomic force microscopy, infrared spectroscopy, you will know that we can get a so-called X-ray of biological cells. So that is also coming up strongly. Okay. Hopefully, Hassan, I have answered you. Let's take any other questions. Let's see. Okay, fire away. Otherwise, I will go into the discussion forum for biophotonics. Those of you who are listening to me, you can directly contact me via the forum. I am usually regular in the forum. So if you have asked me question, I think you have received the answer within couple of hours. If it has been more, then probably you have asked me question in the middle of the night. I generally tend to reply to your questions on the forum within 5, 6, 7 hours time maximum. Though I saw some complaint in the feedback that our questions are not being answered, but to the best of my knowledge, if you look at the forum, discussion forum, every question that has been asked, I have tried to answer it to the best of my ability. So I'm sorry if your question has not yet been answered, but I have not found it. Do me a favor, resend me the question, and I will most definitely try to answer you. What else? Shall I go through some feedback? Well, most of the feedbacks are okay. Many of you are asking it will be helpful if more time is provided for submission of assignments. Some people want a weekly live session. More study materials could be given. The videos are lengthy. Yes, I do understand that some of the videos are quite lengthy. I was given 30 minutes time, but several times I have gone beyond that. It has become 50 minutes or so. You see, I do not know how to condense it. There is a large topic, like, for example, introduction of laser. Laser for me is one of the greatest discoveries of humankind that we see ourselves. Fire, agriculture, wheel, these are something that had discovered like long time ago. Laser is something that you constantly see and you constantly develop. So I wanted to give you a very basic of that. An introduction usually take more time. So some of the lectures have been longer than expected, and I'm guilty as charged. I make absolutely no excuses, and I'm sorry if they are causing too much of a trouble for you. I am henceforth trying to reduce the content of my lecture, but the problem then comes, then you will complain that several of the topic have not been touched, right? So I have to strike a balance. I know, and I will try to, but you have to be sufficiently in tune with it as well. So it's a two-way street. I will try to give some balance, and you have to probably hold your attention beyond that stipulated 30 minutes. So it's a challenge for both of us, I know. Sir, we learned about lasers. What role does the color of laser play in imaging? What does the color and does the color depend upon the type of crystal used? Well, yes, obviously, because color is wavelength. Wavelength is energy of the photon. Wavelength is frequency. Frequency is energy. Energy of your photon. So depending on the energy of your photon, it will change you the color. What role does color of laser play in imaging? Instead of color, consider it from an energy point of view, because energy is the more important thing. So depending on the energy, depending on the wavelength, depending on the frequency, you have different penetration depth onto your tissue. So if you are trying to do some kind of a surgery, laser eye surgery, retinal detachments, retinal reattachment surgery, skin grafting, tattoo removal, these kinds of surgeries, then the wavelength, that is color, will come into effect. If you are looking specifically for imaging, well, depends on what type of imaging. If you are looking for fluorescence imaging, then your fluorophore will emit a particular frequency of light depending on a particular frequency of light it has absorbed. So you have to have an input light, input laser light at a specific color of frequency, so that, so for example, you have to shine green laser, blue laser light on a particular fluorophore, which will emit something in the green spectrum or in the red spectrum. So that will be on the input laser color depends on the output emission of the fluorophore. There are other different types of wavelengths requirement. For example, if you are looking for some kind of a spectroscopy, Raman spectroscopy or infrared spectroscopy, then the wavelength, be it NIR or be it mid-IR, it will vibrate the molecules or the electrons at a different frequency level. Different frequency level, as you know, if it vibrates at a different frequency level, you get a quanta of it, you get a some kind of a signal out of that vibration, and thereby you identify the specific material, you identify the specific compound. So that helps. I hope that answers Om's question. Thank you, Hassan. Let's take some more questions. Let's go to the feedback form. So physics can be taught much clearer, as it would be difficult for a complete fresher to grasp directly about simpler but bit ambiguous topic. Like the way lecturer explained group velocity but phase velocity can be made much clearer. I think one much is too much, but yeah, I get your point. I agree. Physics can be taught much clearer. If so, I'm saying I'm getting two different types of contradiction. Some person says that complete fresher needs to understand, and one person is saying that I want these are already known subject to me, I want a detailed and much complicated subject. So see, it's all about balance. I have to come to a balance which a complete fresher such as you can understand, and person who has a degree in quantum physics can also find it interesting. So since it's a balance, I know I won't be able to make everyone happy. Complete fresher will find certain aspects quite difficult, and people who are quite known in this field, who have spent 4 years, 5 years studying quantum mechanics, will find it very easy. So what can I say? I want to say that if you are finding my physics topics difficult, then it would probably better suit you if you do a refresher course on physics concepts first, and then come to biophotonics. Biophotonics is a specialized subject, so not all topic of physics will be covered, and not every physics topic that we cover I will take it from a high school level. I do try to take it, but then the duration of the course become very high, duration of the lectures become very long. So that is a problem. So we have to somehow come to compromise. It's a great achievement to renew and memorize my subjects in a different way. I congratulate the NPTEL team and Lahiri sir especially to break the boundary of learning. Thank you very much. Though I dislike the term memorization, because memorization is something that I'm not looking for. I want you to understand. Very basics, I see. Very basics are being covered. I want to know these topics in a more specialized manner, in more detail. Well, hang on. I am going in a more specialized manner. The first couple of topics were simply basic. But what is basic for you, for a complete fresher, is not basic. I got two different types of complaints. I wish I have a book to refer. I am telling you my preferred book. It's up to you to buy or borrow that book from a library. Being a novice in a field, I'm enjoying the course. Okay, thank you. Assignment is a bit tougher than expected. Assignments are going to be tough. This is IIT Kharagpur. Come on. It has to have a specific standard. I am not making very easy topics, or we are discussing very specialized topics. If assignments are tough, well, what can I say? Well, you have to study harder. Omj, sir, is doping of semiconductors similar to population inversion? Omj is asking. No. Doping of a semiconductor may somehow indirectly contribute. So, for example, in a semiconductor, you have valence band and conduction band. If large number of electrons can move from valence band, which is a lower energy level, to upper energy level, like electrons go leaving holes that are empty shells of electrons in the valence band, then you have more electrons in a higher energy state. A conduction band is a higher energy state, and empty bands, no or less amount of electrons in the lower energy state valence band, then it is causing population inversion, and more number of electrons will go from valence band to conduction band depending on the doping and depending on your input voltage. So it has a indirect relationship, but doping of semiconductor is not similar to population inversion. It has a role to play in semiconductor lasers, that is. Hassan Rab, it's okay, sir. Longer lectures are better than short information. At least we get complete information. Well, you tell it in the forum. Write it, Hassan, in the forum that you are okay with the long lectures. Rest of I get complaints. I have to ask you. I give you the information on the history of scientists. Some people complain that it is too much. We don't need to know who died or where he lived or whether he went to war or what happened. This is a waste of our time. So you tell me, if it is actually, if the majority decides that it's a waste of everybody's time, then I will obviously stop. I personally like to read about the life and times of various scientists, and I bring that to my topic. If you think it's a waste of time, then I will stop. Were okay to me being an average learner. Sandeep Chatterjee. Yes, sir, the length of the lecture and the pace of the course were okay to me being an average learner, considering the fact that course is multidisciplinary. Description of basic helped a lot. Thank you, Sandeep. I cannot please everyone with this course. I received certain biology comment from biology background students stating that well, biology could be described much easier, and gene has to be done in a completely different way. This is not a course on genetics. This uses genetics. This is an interdisciplinary topic. So if you are looking to get information on genetics, this is not the course. Similarly, if you are trying to look at information on quantum physics, again, this is not the course. I am giving a bit of both so that it helps you understand where biophotonics is. This is biophotonics at the end of the day. So I have to pick and choose somewhere. And many of the times, whatever I am picking is something that I am understanding or I find important. It has to be my bias. See, if I am unable to understand, there are several topics in both quantum physics and biology, genetics, which I do not know or do not understand. If I am being asked to teach you that, I will be doing a disservice to you. I'm not, I told you, I'm not a person to discuss or give you detail on central dogma, because I'm not a biologist, right? If you ask me some kind of medical information on how a particular brain surgery is to be done, I don't think I'm qualified enough to ask you that. So this won't work. This won't work. So, Prashant Sharma, Sir, is it a right decision to start learning biophotonics in second sem of MTech because I'm from wireless and optical communication? I've studied photonics integrated circuit. This is a very specific question, Prashant. I do not know whether you need to learn biophotonics from second semester or first semester. It depends on you. I don't know. I cannot answer this question whether it depends on you. How are you finding the course thus far? Categories of speech sounds are called. Himanshu Gupta. I do not understand, Himanshu. What do you mean categories of speech sounds are called? Anyway, let me get back to Prashant's question. Prashant, it depends on you. I cannot tell you which semester you would like to attend biophotonics course. See, this is online course. So you can take it. The idea is you can take it at the leisure of your own on time, at your own leisure, but at your own pace. However, if you need a certificate, if you want a certificate out of it, you have to register and go through the proper regime. So that depends. If you think that you are too much burdened with load and you are having several different subjects to follow, then obviously you cannot do justice to both. It depends on you. Himanshu, I do not understand your question. Categories of speech sounds are called. Is it a question? Write something up. I will try to answer. What else? Let's get to the feedback. Very nice, very useful, comprehensive. If video transcripts are available as document, that will be helpful in exam. I don't think you will have transcripts available as document, but since they are in YouTube, there are transcripts available and you can copy paste them. I don't think NPTEL provides you with transcripts. At the same time, several of you ask me whether I can take the assignment after the stipulated date or after the deadline, or see, I won't be able to do that. It's a centralized system. I make the questions, I send it to the administration. It's like CBSE class 10th or joint entrance examination. We are only allowed to set the question up and give it to NPTEL administration. NPTEL administration then do all the administration thing, i.e. Uploading the course, checking, and setting up the question papers, etc. Well, checking is done partially by me as well. I do not have a direct call on how to accept students, or many people ask me whether I can register them after the deadline. These deadlines are quite strict. They are like any other centralized examination. I have no hand in that. Even I do not know till the assignment or till the question which actual set has gone through. I prepare multiple number of sets, multiple number of questions, and it's I don't think it's random, but one of that is picked. Which one is picked, I do not know. So it's something they do for security, like any other centralized examination. Will the final exam in April be also be MCQ type, MSQ type, M physics? So the final exam in April will be MSQ, where more than one option will be valid. Understand this. I'm telling you here in the live session as well. There will be options, there will be questions, there will be multiple options to that, and more than one option of that will be correct, and you will get full marks only when all the correct options have been accepted, or you have answered that. Pankaj Keshri, what type of biophotonic related research is going on in IIT Kharagpur? Well, several type of biophotonic related research is going on. We are making ultra fast diagnostic tool. We are trying to detect coronavirus at a record speed. Maybe you have seen some newspaper reports. We did make a coronavirus detection tool, but that's technically not biophotonics, but we are overlapping, our interests overlap. We are trying to go for early detection of oral cancer. Oral cancer is basically Indian cancer. This oral cancer is a menace, and it is mostly available in the Indian subcontinent, especially India. So we are trying to utilize biophotonic technologies for detection of early detection of oral cancer. So these are some of the many topics that are going on. You have to look into our website at IIT Kharagpur. You have to look into our website and see the website of different professors who are related not only to the electronics department. There is a school of medical science where biophotonics or photonics or biological applications are going on. There is biotechnology department, there is bioscience department, there is chemistry department, school of nanoscience and technology. We have a plethora of department, and there are several different kinds of experiments are being going on. Dr. Neeta S, thank you for blending physics and biology. Well, Dr. Neeta, thanks to you, so that you have come out of your comfort zone. I am hoping you have come out of your comfort zone, and I understand that there might be some topics which I did not take, or I simplified it or oversimplified it, especially cancer and virus detection. So if that has happened, again, apologies. If we have constant interaction, probably I will be able to smooth over some of the mistakes, lacunas that were there. Himanshu Gupta, phenomes or morpheme or photonics or autonomes or glyphs. Again, I do not understand. What does that mean? Himanshu? Categories of speech sounds. I don't know. I don't work on speech. I do not work on sound. Himanshu, I don't work on sound. I work on light. I do not know what these are. Mahima S at Himanshu, phonetics. Okay. Shubhrajit Sarkar, sir, can you tell us some LIDAR-based project going on? Well, you have to contact the LIDAR guy. I am not a laser-based radar system. You have to contact other professors. These are communication and, well, radar type of. There is a strong G. Sanyal school of telecommunications, I believe, in IIT Kharagpur. So that can help. Himanshu, I'm sorry, I won't be able to answer your question. You are asking me a question on phonetics or sound. I don't work on sound. I work on light. So not my area of expertise. Whatever I say will probably be wrong. Well, most definitely be wrong. What else? Okay. Some more feedback. I'm currently pursuing my BTech in electrical. I have no difficulty understanding my concept of bio. The teaching style is excellent. Thank you. Thank you very much. PPT or transcript of the video may help us. Yes, PowerPoint presentation are available. Question not seems to be bounded by syllabus. No, question are seem to be bounded by syllabus. Please, assignments are so tough. Give it in an easy manner. Okay, I will ask. I will try to mellow it down. Probably a couple of them have become difficult, though the majority are stating, I have the statistics here. The difficulty level of assignment 60% and above are saying that as expected, and 10% are saying easier than expected. So I don't know. If you have found the topic difficult, the assignment difficult, I think you have to take it a bit further. Please, very informative lecture. Thank you. Thank you. Some questions are difficult. Okay. It's definitely increasing the thinking capacity. Well, thank you. This is the main aim, to make you curious. Can you kindly confirm the answer for the formation of sigma or pi bonds as given in the assignment? I think this is Professor Deepti asking me this question. I have answered it into the forum. You can look into the forum. I have probably given you this answer into the forum. So sigma bonds are stronger, pi bonds are a little bit weaker. That's it. Professor has a very good way of conveying certain concept in the course. Thank you. Eager to learn, development, good talk. Thank you, most of them. This week classes were good. Okay, hopefully. Thank you. This is which week? Week 3. Week 3 classes were good. Okay. The question on genetic material has a correct answer as Mendelian character, but all hereditary is not as per Mendelian genetics. Can you kindly look into this? You want me to look into the assignment or discuss about Mendelian characteristic? So I need a bit more onto this, but I completely agree that all hereditary is not as per Mendelian genetics. You are asking me question on the genetics part, and I assume that you are hinting towards epigenetics. I could be wrong. I need more information from you What exactly are you handling? I did not discuss epigenetics. So for those of you who might be curious, epigenetics is nature versus nurture. Epigenetics is the characteristic form. Again, in my layman language, I'm again not a biologist, because of the environment, not because of hereditary, but some amount of change happen because of the environment in which a particular organism is born. If the environment changes, there is some sort of adaptation coming up. So if you are talking about epigenetics, yes, that exists. Not all hereditary are Mendelian, but come on, this is not a genetic course, so I made it simple. I didn't discuss epigenetics to make it simple. Sir, is it possible to know the nutrients of a food by using biophotonic technique? Yes, you do a spectroscopy on a particular food and then figure out what are the vibrations, and from the vibration you figure out the molecules, from the molecules you figure out what is the matter. Yes, spectroscopy. Sir, lectures are really good, sir. Thank you. M Physics. I don't know your name, so I'm referring you by your screen name, M Physics. Thank you. Pankaj Keshri, sir, your lectures always inspire me. Thank you, Pankaj. That is the idea, for you to take on this mantle from me and you become an expert in biophotonics and do some fantastic research. Omj, biophotonics has enhanced my curiosity in newer and ambiguous topic. Thanks. Is it an ambiguous topic? Ambiguous means unclear. So, okay, I would take it as a compliment. I don't think biophotonics is ambiguous. Biophotonics is interdisciplinary, but I get your point. Yeah, this is what we fight for. This is what is the main reason for us to teach you, so that you become curious, you like these things, and you come out of your comfort zone and tell us what you want, or you take this forward. I mean, this is the onus, the responsibility lies with you. Jonathan Thomas says, sir, can biophotonics apply into biosensor for mass identification of disease? Yes, absolutely. The seventh, topic on the seventh chapter was optical biosensing, where I gave you my own research perspective, the type of research that I do. I know I will get a couple of hate comments because of that. Why am I teaching my research and not someone else's research? So here I have tried to go for screening of coronavirus. I have discussed that in a concise and precise manner. Yes, so Jonathan, biophotonics, one of the major potential that biophotonics has shown is mass screening. You want to screen quite strongly, the quite rapidly, a large number of populations. So that is done. Shurajit Sarkar, how to choose a topic to write a paper based on, or to do a whole PhD on that? I don't know, what do you mean? How to choose a topic to write a paper based on, or to do a whole PhD on that? Shurajit, I do not understand your question. What does that mean? You want to write a paper on what? I do not understand this question. I mean, at the end of the day, if you are asking for a PhD, I mean, whether you will do a PhD or not, the only person who is capable to answer that is you yourself. No one can, and no one should tell you you should do a PhD or you should not do a PhD. PhD, trust me, is not the ultimate source of research or ultimate source of goal. There are several fantastic scientists all over the world who do not have a PhD, and they have gone quite far. So that is not the final or ultimate criteria, but it does help. At least it has helped me. So what has helped me might help you, might not. So it's up to you. Shubhajit Sarkar. Okay. Thank you. Informative session. Great classes. Okay. I think most of the feedback were positive. Couple of them thought that it is either very easy or very tough. Some of the assignments are tougher. I will try to look into that. And if you are looking for a book, I have mentioned a particular book or particular sets of book. At the end of my topic, there are several a slide dedicated for the references. So you can go to that and look for which topic you want to pursue and thereby borrow that particular book. So is that the end of our session? Are there any more questions? Most of the questions on the forum has already been discussed. Sejal has asked me question on resonators, but then she got her own answer. So she got the answer herself. So that is very good. Here I would like to give a shout out to, I think, Megha Mehta, sorry, beg your pardon. And she has actually taken the time to go and answer the questions that I asked in the earlier sessions about why solar system is disc shaped, whereas the atoms are spherical. So some of the questions that I have asked you, which are not part of the assignments, at least make some attempt to answer them. I would love to see those. Is early detection of cancer using biophotonics possible? Yeah, Prashant, look at some of my lectures. I have been discussing that for quite a long time. Yes, it is indeed possible using biophotonics. So Megha Malhotra, well done. Then Chandrasekhar. I quite like Chandrasekhar's question on optical coherence tomography. He has gone through several papers and he wanted to know whether Chandrasekhar Narayana, whether he has correctly understood or not imaging of a brain tumor. So Chandrasekhar's question was also quite interesting. I think I have tried to answer that. Prashant obviously asked me several questions. Length of fluorescence, length of phosphorescence, fluorescence, S1 and S2. Many of you are asking for setting up WhatsApp group. See, WhatsApp group has a difficult problem with privacy. Several of the people who give their number into the WhatsApp group, their numbers get, taken out and used in an improper manner. So I am skeptical, but obviously if you want to set up your own group with your own friends where you want to discuss biophotonics over WhatsApp, by all means do it. NPTEL won't be authorizing that, and I won't be participating in that either. The only authorized platform from NPTEL to discuss is the forum or chat boxes or YouTube live sessions such as this. If you want to set up a WhatsApp group, by all means do that. I think several of you have already done that. It's just that it's not official. Yes, I think that takes us to most of our questions. You can ask me if you have not asked me here the other questions on in the forum. Utilize the forum. Even if you have no questions, go to the Biophotonics forum where several questions are answered. You can look at those questions. Maybe some of these questions you wanted to ask, but you are too shy or too busy or too indifferent to ask. So they might have already been answered. So go to the forum, look into that. So that specifically is all the questions that we have for today. If you have anything else, I'm waiting. Let me see. Let me refresh just to see if any other questions have come up. I think here also I tried to answer all the questions. So if there are no more questions, then I would then close the session. It was 1 hour, and I think I have tried to answer majority of your questions. I think I tried to answer all of your questions, which have you asked. Thank you all for saying good words. Thank you all for liking the course. And I will be available to answer. I am unable to join the Google discussion group. Why? You have to register for the course first, Physics. You have to register for the course first, and then it will automatically come. Otherwise, just send email and I will try to help you out. So that is it. We are almost halfway done. Thank you, Prashant. Halfway done, I think. Yeah, week 6 is also live, so halfway done. 6 more topics remaining. So again, remember, this was just an introductory course on biophotonics. There will be biophotonics 2 and biophotonics, hopefully 3, depending, coming up, where specific part will be taken, and I will take it to further deep. If not me, then some other lecturer, some other professor will take it to further details. Here we are just giving you information on the basic, or I am giving you information on the basic topic of biophotonics. So instead of calling this course biophotonics, I think I should have called it Introduction to Biophotonics. That might have helped. So in the next subsequent biophotonics part 2, maybe some of those topics which I have not discussed in detail will be discussed. But for the time being, this will be an introductory course where people from different discipline, different background can come together and learn something new, something fun, something imaginative, something curious, and then we will see. So thank you very much. I think we shall end here. This is not the only live session that we are going to have. We will have another live session pretty soon. So keep your questions ready, and happy learning. Thank you. Thank you very much.